For a basic file operation, there are 3 steps. The first step is to open a file, and you can use fopen function to open a file, and it will return a file ID. If the operation is successful, the file ID should be a positive integer. And then you can use a file ID to either write data to a file or to read the data from the file. And when you're done, you're going to use the fclose function to close a file identified by the file ID. This is an example to save data into a binary file. So first, we will create 2 data sets. One is called the data. It is a vector of 100 random variables, and it is double precision format, and I use it as a column vector. And this is for the easy comparison in the following fread function. And then next is a column vector of 100 integer. The type of integer is int32, and it is starting from 1 all the way to 100. So we're going to store the 2 data sets in one file, and we name this file called random_data.bin. So first of all, we're going to open the file, and then we'll open the file for write. So we specify the mode of operation. And then we check to see if the file ID is greater than 0. If it is, which means the file is opened successfully, and we can do the file output, that is to the write operations. And otherwise, we just printed out the error message. Okay, so if the file is opened successfully, what we're going to do is to write out the data in 2 sections. One is the 100 double precision data, and we will use a file ID and the data followed by the so-called precision. This precision is specified as float 64, so it will write the data out as double precision format. And since this is 100 double precision values, it will occupy 800 bytes of space, because one double precision number will occupy 8 bytes, so 100 will occupy 800 bytes. Then we're going to do the next step is to write the second data set, which is 100 integer. And we will do the same. We'll use fwrite function followed by the file ID and the data. And then we'll specify the data type as int32. So in this case, we're going to write altogether 400 bytes to the file. And because the int32 needs 4 bytes for one integer. So 100 integers will use 400 bytes of space. So altogether, this entire file will have 1,200 bytes. When we are done with the writing data to the file, and we will close the file using fclose. Okay, so let's see how it works. If we select this section and we run this section, here we go. We got a new file. So let's see if we can check the file size. So we will go to that specific folder, script, and then we will find this, and we right-click, go to Properties. You'll see that's exactly the size of the file, 1,200 bytes. Next, we're going to read the data back. So we're going to do almost the same thing. The only difference is we're going to use fread to read the data back. All right, so we're going to open the file, and with the mode as read, then we check if the FID is greater than 0. If it is positive, then we continue to read the data. So here is what we're going to do. We're going to read the data from the file. We first read 100 double precision values. So we will specify the file ID and the number of double precision values to read, and also specify the format, which is double precision, float 64. And after that, we're going to read the rest 100 integer. So we will continue to do that, is use the fread function again, specify the FID, and then we're going to do the 100 as the number of integers to read, and then we specify the type of integer is int32. And let's give it a try. Okay? So if I hit run, we got data read, which is over here, and data int read, which is here. So they are all, one is 100 double precision number over here, and the data int read is also 100 double precision number. So here is the explanation, because fread is always output the data as double precision, so it changed the data type to double precision, but its value will not change. So let's just compare the data that we stored versus the data we read back. So over here, you will see that the original data as data int. So I just click it, data. All right, and we will see here we put the data that from the file is data read. So I will click here again, data read. And you will see we have two sets of data. In order to compare them, I just need to copy this over here. And you can easily compare that they are all the same. Okay, so let's just delete this column. I don't want to change that. And we can also verify the values of data int over here versus data int read. They're all the same. All right, so this is very important. And when we read the binary data, we know that it has 1,200 bytes. And the first 800 bytes are for 100 double precision values. So we read 100 double precision values. And then after the 100 double precision value is read, the pointer that inside that file points to the 800th byte in that file, or the 800 first byte of the file if you start the first byte as 1. And then we're going to read from that point for another 400 bytes and interpret it as the integer, the int32. Now with that in mind, we can actually do something different. So we can say we add another read. So the data will be to data read 1 equals fread, and then we have a FID, and in this case, let's do 50 double precision here. Okay. Now I also make changes to the previous statement. So instead of 100, I do 50. So if I do this, it still works because the first read will read 50 double precision number from the file, and the second read will read another 50. Altogether is 100. So I have a 100 double precision number in that file for the first 800 bytes. It will be fine. It's just like instead of the data read will hold 100 data points, it will hold 50. And the other 50 will be in this variable. So if I run this, let me just select this and run. I think we got an error here. So I just make a change, and then we will run the section again. Now, over here, you will see that the data read will have 50 double precision, and the other one will have another 50. And of course, the data in int read will still have the 100 values. So if I check this, they're all good. And if I check this, all looks good, right? Okay, so the next thing I'm going to show you is that I'm going to delete this then statement, okay? And still going to read 100 values. But in this case, I marked the data precision wrong. So if I say it's 32, let's see what will happen. So if I hit run section again, and then we'll look at the data read here. It's 100 double. Well, when you look at the data, it's all garbage. So the reason why is that in this case, what we're going to do is to read 100 single precision values. And for single precision values, it only occupies 4 bytes. So basically, we took the first 400 bytes and interpreted as 100 single precision values, because the coding is messed up, and what you get, the data itself, is also messed up. So in other words, if you specify the precision wrong, you will not get an error from the program, but the data itself is unusable. And similarly, because we only read 400 bytes for the first read, and if we try to read the next 400 bytes and try to interpret as integer, we know they are not integers, okay? There's the other like 50 double precision values. So if you try to interpret the double precision value into integer, what happens is that you will get all garbage data. So if I click here, it's a data int read, and you will see that they are all over the place. So the data are not correct. In conclusion here, when you read the data from the binary file, you must know that the organization or the format of those bytes in that file. And if you know the correct format of the file, then you will be able to get the data back correctly. Another thing is important is that in the end, after you finish the read, you always close a file using the fclose function.